welcome to this video. And in this video we're going to talk about point slope form. So in our previous lessons, if you haven't checked that out, then please check that out if you want to know about it. In the previous lessons, we've talked about in the first lesson we talked about slope-intercept form. Y is equal to mx plus b. Another form of this is y is equal to m times x minus a, and a represents the x-intercept, and b here represents the y-intercept. Okay, so the y-intercept is the x-intercept. Okay, so this was the slope-intercept form. This is mostly used because if you further simplify this, you're going to get into this. Another thing that we talked about in the next video is the double-intercept form, which is this thing, x over a plus y over b is equal to 1. We derived it. We also derived this thing, in one of those videos. And if you want to know about this, okay, then please check out my previous videos. They are given in the description box. Okay, today it's time to learn point slope form. Pay attention here. Okay. So what does point slope form means first? So you have a point here, as its name suggests. Everything actually is in its name. Okay, about its form. It says point. So you got a point here, and then a slope. Okay, so a line passes through the point, and what you know about the line is that the line passes through the point. Okay, so you know the specific point that it passes through. Okay, let's call it x naught, y naught. So you know the point that it passes through, and the second thing that is known is the slope. And using these two, you can specify the line. Okay, you can specifically, in particular, specify what line it is. How you can do that? Geometrically, when it's possible. If you know the one single point that the line passes through, and if you know the inclination, slope. Okay, if you know the slope, then you can draw the line. Okay, you can draw the line with easily. If it can happen geometrically, this should also happen algebraically in the form of equation also. It's possible to express the equation given the point and the slope. Okay, and this is what we're gonna do. So now let's derive the equation. Okay, so you got everything clear till this point. So let's derive the equation of this form. So x naught, y naught, and okay, you know the slope of this. So slope is the second ingredient, the second input that is known. Okay, slope is known here. We know. Okay, how do you derive this equation? You have to first of all take a variable on the line, which will be the generalization for the equation. Because take x comma y variable. Okay, x comma y. This represents that any point. It's true for any point. Okay, so when the equation is ready for x comma y, you can plug in any point and see that the equation is satisfied. Okay, so we've taken x comma y as the variable, and this is the point that is known, and we know the slope. Okay, so these two ingredients are the input, and this is just for deriving the equation. X comma y is just for deriving the equation. So m, you know, it will be, okay, so you're gonna find m using these two. Okay, so it will be y minus y naught, okay, divided by x minus x naught. You could use this first and written as y naught minus y and x naught minus x. That as well, that still will give you the same answer. But this is the standard form. Okay, so stick with the standard form. There's nothing wrong with swapping these two, but standard form is actually good to write. Okay, so it will come out to be y minus y naught is equal to m times x minus x naught, and that's the equation. Okay, that's the equation that we're looking for. So what inputs takes? It takes the point that is known there, x naught, y naught. So x naught will be here, y naught will be here. The second thing that it needs is the slope. Given the slope, the equation will be ready. Okay, so note this down. You should note this down. Okay, if this is the topic that you actually need. Okay, so I hope you have noted this down by pausing the video. Let's go further now. Okay, so this is the form, and this was the whole derivation of this form. So we have derived it, so let's go further. Let's give an example in which we'll try to find the equation of the straight line. Let's say you have a straight line here which passes through 3, 5, okay, passes through 3, 5, and slope let's say is half. Okay, the slope is half. Drive its equation. So we're going to drive its equation. So the equation will be, okay, look at here. What is the equation will be? Y minus I naught. So let me just write the form for you because I don't want to do too direct because we are learning the topic. So m times x minus x naught. Okay, so y minus y naught is this 5, meaning the y value of the point, which is 5, ordinate, okay, and m times x minus abscissa, which is 3. Makes sense here? Okay, so I should plug in m, so which is half. Okay, so it will be y minus 5 is equal to half x minus 3/2. Okay, so you ready? You have the equation. If you solve this other term, so y is equal to half x plus 5 minus 3/2. So y will be half x plus 10 minus 3 is 7/2. Okay, that's the equation. This is the equation of the straight line, the required equation of the straight line that we were looking for. Okay, so that was the example. And now I've just given you the example. You could do any sort of problem as well. There might be some twisted, tangled problem in your textbooks that seem a little harder, okay? But they are not actually that much harder, okay? You need to comprehend them, okay? And yeah, then you'll be able to do. Because the problems will be based on just this concept, okay? Now, let's talk about one thing. Instead of the points-law form, you could also have 2 points form, or maybe double point form. It might also be called double points form. Okay, double points form. By its name, you can think, okay, you can recognize the fact that there are 2 points known lying on the straight line. Okay, so I want to call it, the first one is x naught, y naught. Second one, I want to call it x1, y1. Okay, so yeah. So these 2 points are known there, and we have to find the equation. First of all, it's geometrically possible to actually draw one point, because if you have on one line, because if you have 2 points there, there's one and only line which actually passes through the point. So if you can draw it, okay, if you can draw it, if 2 points are known, and you can draw one single line, which is the line there, okay, then you can for sure derive this equation as well. That's why using these 2 inputs, deriving the equation is possible. Okay, making the equation, writing the line's equation is possible. Did you get it? So let's pay attention. These 2 points are known. How do you derive this equation? Tell me. So first of all, give me some time to actually, to come up with this.
I'll take m.
Mm-hmm. You derive m using these 2. Okay, so look. So what do? You're gonna use the same formula the earlier. Y minus y naught is equal to m times x minus x naught. Why are you gonna use the same formula? Because it takes just 1 point. So plug in 1 point, and then it takes the m, meaning the slope, which is not known there. Okay, in the previous form we had the slope and 1 point given, slope and 1 point known. Okay, and if you could figure out the equation these 2, and here the 2 points are known. So what you're gonna do is we're gonna use either of the points, okay, so any point you like, any point, so 1 point, to derive this equation. And one extra thing we're gonna do is we're gonna derive its slope as well. Okay, so derive its slope as well. So for this form we're gonna do this then. Okay, so this is the procedure that we're gonna follow. For the previous form, this was the procedure, because you use 1 point and then the slope to derive the equation. For this, you use again either of the points that you like to use. Okay, any point. So any point here, and then derive the slope using these 2 points, because the 2 points are given so that you could derive the slope. Okay, so let's do it. So it will be y minus y naught, the same equation, but the slope we will derived using these two. It means, let's call it y1 minus y naught divided by x1 minus x naught times x minus x naught. Okay, so we use the point y naught and x naught to plug into it. Okay, we could also use another point, y minus y1 is equal to y1 minus y naught divided by x minus x1 times x minus x naught. Okay, so yeah, these two turns out to be the equation. You could use any of them because they are both the same actually, but the difference is that you have plugged in another point. Okay, so let me just write that down clearly above here. So the equation for this that we got is y minus y naught is equal to y1 minus y naught divided by x1 minus x naught times x minus x naught. Okay, that's this equation. If you plug in another point, that's y minus y naught is equal to y naught minus y, okay, you know what I'm writing, okay, times x minus x naught. If you find the equation by swapping this, is still fine, you get the same thing. Okay, so I could use this equation, and it's not that hard to memorize. It's the same our old equation. Instead of m, we've written this. Instead of m, we've written this. So it means that expand m. You have to do extra work here. You have to find the m as well. Make sense? So let's give you an example. So yeah, let's give an example. Same drawing, but I'm going to replace this with real values. Okay, I'm going to give you real values. Let's suppose that this point is 2,4, and this is above here. We move a little to 3. Let's say this goes back. This goes to, let's say, 6. And let's come up with the equation. Let's come up with its equation. What will be the equation if you know these 2 points? It will be y minus y naught. So let's use maybe this point for plugging in, okay, for the increment of x naught and y naught. So yeah, 4 is equal to the slope, which will be 6 minus 4 divided by 3 minus 2 times x minus x naught. So let's use this. So this will be y minus 4 is equal to, this thing is gonna be 2 over just 1. So yeah, it's 2 times x minus 2. So y minus 4 will be 2x minus 4. And it means that this 4 cancels out. We have the equation y is equal to 2x. Y is equal to 2x. It means what? The y is twice as, meaning the y value is twice as the x value. This is also vividly shown here, okay? I mean, very clearly, you can see that as well, that the y value is twice as the x value, 2 times x. The y value is twice as the x value, okay? This is the equation of this kind of line, okay? This kind of, let me do it properly, this kind of line. Actually passes through the origin, okay? Actually, let's draw it, and this passes through the origin. Then the y value should be twice as the x value. If it doesn't look that way, then I'm just thinking that we need to put extra inclination. But there is no scales here, so it can't be perfect. Okay, so yeah, just think that this is the equation of y is equal to 2x. If you had the scales here, the scales written, then you could see, if you draw it properly, that the y value is twice as the x value. Okay. So we've done one example, and I hope this was helpful. I hope you have learned something new in this video, and see you in the next video.